All right, so lesson number 8 is on what we call parametric equations. So like I said, we're going to do a lot with this second semester, and it's going to lead to more important topics like polar coordinates and so on. And I'll give you a preview of those today, but for right now, we're just doing some very basic things with parametric equations. So basically, it's going to be useful in some of these problems to introduce a new variable. A lot of times we use t because it's related to time. So maybe you have a boat that's traveling at 30 miles per hour in the westward direction. Then I would represent its distance by 30t, right? 30 miles every single hour. So a lot of times we'll have t for our parameter. So it's going to look a little bit strange because you're going to have two equations to create one equation. So it says x equals t plus 1 and y equals t squared minus 3t is going to be a set of ordered pairs. So we're still going to end up getting x comma y, but it's just weird when you look at the setup. So we have x equals t plus 1 and y equals t squared minus 3t. So in order to do this, we use our parameter t, and we input different things for the t value. So if I have x equals t plus 1 and I have t equals negative 3, then I have negative 3 plus 1, which is negative 2. Then I have negative 2 plus 1, which is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3, and 3 plus 1 is 4. Okay, so those are all of the x values. Then all of the y values, if I plug in negative 3, I'm going to have negative 3 squared minus 3 times negative 3. So I get 9 plus 9, so I get 18. I get 4 plus 6, which is, sorry, 4 plus 6, so 10. I get 1 plus 3, which is 4. 0 minus 0 is 0. 1 minus 3 is negative 2. 4 minus 6 is negative 2. And 3 squared is 9 minus 9 is 0. Okay? And this still represents ordered pairs, so points. So when I plug in, for instance, t equals 3, I get the point negative 2 comma 18. I still have my x comma y coordinates. Okay? So I could graph all of those different things. So I could have negative 2 comma 18. And I could graph negative 1, or not negative 2 comma 18, negative 3 comma 18, right? Could have gotten a bonus point, guys. Already. Negative 3 comma 18. Negative 2 comma 10. Negative 1 comma, or sorry, what am I doing? No, it is negative 2. It's my x and my y. Man, I'm looking at the wrong thing. Negative 2 and x. So it is negative 2 comma 18. And then it's negative 1 comma 10, my x comma y. And my 0 comma 4, my 1 comma 0, my 2 comma negative 2. And you could continue to graph it, 4 comma 0, and so on. Can you tell what shape it's going to be? It's not a line because it goes back up. Half of a parabola? Yeah, it doesn't really matter. It is part of a parabola. You're correct. All right, so it is part of a parabola. So we can figure that out by doing what we call eliminating the parameters. So sometimes I'll say put in rectangular form. I might use that phrase, especially when we do go to polar coordinates second semester. So I might say put in rectangular form. It just means in the x, like y equals something with x. Okay? So if I have x equals t plus 1, and I have y equals t squared minus 3t, and I want to put it in this other form, what I end up doing is I solve for t for one of them. Can you guys tell what t is going to equal? T equals what? You can solve it for the x equation and the y equation, doesn't matter. Natalie, do you have it? Yeah, exactly. T equals x minus 1. That is the easiest way to get t by itself. So now in the other equation, whenever you have t, we're going to replace it with, surprise, surprise, x minus 1. So we're going to have y equals x minus 1 squared minus 3 times x minus 1. That's a 2. All right, and we can square it out. If we FOIL, we get x squared minus 2x plus 1 minus 3x plus 3. So we get the parabola x squared minus 5x plus 4. All right. So let's show that these are the same thing. So you can actually graph parametric equations on your graphing calculator. So they probably don't seem super important now, but we're going to use parametric equations a lot when we talk about projectile motion. So imagine I'm shooting a human out of a cannonball, right? It's always a guy, it's never a girl, but I'm shooting this guy who is, you know, not very smart out of a cannonball. And if I want to know how far he's traveling, that's an x component. And if I want to know how high he goes, that's a y component. So a lot of times we'll have parametric equations in terms of time for that. So like 1 second later, he's this many feet out, he's this many feet up. Okay, so we actually do use parametric equations a lot. So let's go ahead and look at the graphing calculator, and I'll show you how to graph parametric equations. All right, so you're going to go to Mode, and right now you have Function highlighted. I don't want Function highlighted. I want PAR, Parametric, highlighted. So do you guys all have a calculator? You can grab one on my front desk if you need to. There's one on my other desk over there too. Yeah, so you're going to do PAR, parameter. Or get next to someone that has one. All right, and then you're going to get out of there. You're going to do second quit. So now when you hit y equals, it looks totally different. Do you see it? So it has x equals and y equals for each of the graphs. Okay, so in our case, we had x equals, what was it? T plus 1. Okay, so that's what we need to put in. So for x equals, we want t plus 1. So how do we get t? The same way we got x. Do you guys see? We hit x, t, theta, n, that one button, and we say t plus 1. Should I turn off the light? Can you guys turn it off? All right, and then the other one. So if I want the y value is t squared minus 3t. So I do t squared minus 3t. Oops, not 37. I don't know why I just did that. 3t. All right, and then we'll still do the zoom 6 for the standard window. Okay, so when I hit graph, as long as you did the zoom 6, you actually do not get the whole parabola. So if you hit window, you'll notice that your window looks totally different too. It says T-min, T-max. All right, notice when I did the T-table, T-table, when I did that T-table before, I had negative values and I had positive values. Do you guys see? I had negatives and I had positives. All right, but when I look at my window, so if you hit window on your graphing calculator, I don't have negatives and positives. It says my T-min starts at 0. I don't want it to start at 0. Let's start it at like negative 50, and we'll go up to 50. And you don't have to adjust anything else. So now when you hit graph, it's going to draw the rest of that parabola. Okay, it takes a while sometimes. Does that make sense? So it draws everything in. So it's exactly the same thing. It's just a different way of writing this equation. It's using what we call a parameter. Yep. All right, so let's do the next one. So we had it's just a parabola with the equation y squared equal, or not y squared, y equals x squared, what was it, minus 5x plus 4? Is that what it was? Last one? Yeah. All right, so why do we use the parametric equation? So a great example of usefulness comes from the classic velocity, acceleration, and height problem from throwing a ball into the air. So a lot of the textbooks that you will see will use this equation. So it will say h of t equals negative 16 t squared plus v sub o times t plus h sub o. So v sub o is the initial velocity. The little subscript of 0 means at time 0. H sub o is the initial height. But when we use this in textbooks, that means that our projectile, the thing we're throwing into the air, has to be going straight up. How many things do we know that go straight up? I mean, if I'm hitting a golf ball, do we want it to go straight up? No, it's going to come back and hit me in the head, right? I don't want to hit a golf ball straight into the air. I don't want to throw a baseball straight into the air, right? Unless you're playing a sad game of catch with yourself. I don't know. So you don't want to throw things straight into the air. So the v sub o, a lot of times your initial velocity goes into two directions. It goes up and it goes out. Okay, so in physics, you will use x components and y components. You're going to talk about how fast it's going in the x component out, right, and how high it's going in the y component, right? So I'm not going to get into too much depth with this, but this is why we do parametric equations, why we define things parametrically. Okay, because it's really important when it comes to projectiles. You know, if you're going to throw something into the air or, you know, project something into the air like a bomb or something, you want to know where it's going to end up, right? You want to know where it lands. That's why Dr. Vesper is very good at what he does. That's what he does. He talks about projectiles, things that go up. All right, so for this one, it says eliminate the parameter, graph the parametric in parametric mode to check. So we're going to do the same thing. We're just eliminating the parameter. So we're going to solve one of the equations for t. So it's pretty easy to see which one we can solve for t. It's pretty quick to do x over 2 equals t. So in our other equation, we have y equals 3t minus 1. So we're going to replace our t value with the x plus 2. We're going to put it right in there. So we're going to have y equals 3 times x over 2 minus 1. So we get y equals 3 over 2x minus 1. We get a line. And you could do a little t-table with the extra parameter, right? And you could do different points, and you'll see you have lots of points on that line. So if you were graphing to check, so we have 2t and 3t minus 1, we just go to our calculator. Under y equals, we do 2t, let me start out. 2t, and we do 3t minus 1. Was that what it was, 3t minus 1? Yeah. And you should get a line that goes through -1 for the y-intercept. It has a slope of 3 over 2. So it takes a little bit. So, and you do get that. So you can check, but it's the same thing. Okay? So it's just a different way of writing an equation of a line. An equation of anything. Okay, if it says error window range, do your zoom 6 and change it from Tmin and Tmax to make it 50 to 50 again. Okay, I'm sorry, that was Natalie. I was telling you. I'm like looking at you. Yeah, so did you do negative or did you do minus 50? Do negative 50. All right, so same idea on the next one. So go ahead and try to solve for t, or solve for t and then plug it in. Should make t step. Yeah, make it like 0.1. Are you going to get these down? Yeah, if you have the plot one highlighted on your calculator, a lot of times it will say like error. So just deselect that and it will be fine. So if you run into problems and you can't graph it now. All right, so we end up getting y equals 2x squared minus 5, which is a parabola. So even though this original parametric equation doesn't look like a parabola, it ends up actually being a parabola, right? It works out. So it may not look like something familiar to you, but it works out. Yes, Julie. Okay, if only part of your parabola is showing, remember that's when you go to your Tmin and Tmax. So you're just going to go in here to mode, or not mode, to window. And you're going to change Tmin and Tmax to negative 50 or 50. And then you'll see the rest of it. Did you do that? What do you have for your Xmin and Xmax? Do you have negative 10 to 10? What do you have for your T-step? Okay, try like 0.1. Yeah, and T-step is just when it's doing a T-table, like the calculator is literally doing a T-table and plotting every single point. It's telling you how many points to plot. So it's like saying, okay, start at 0, and then 0.1, and then 0.2, and 0.3. Yeah. You're only getting half? I don't know why. I'll come around and look at it in a second. All right, so it says let's revisit inverses. So suppose you have y equals the square root of x minus 1. All right, you can make that into a parametric equation. All right, you can just let x be t, and then y equals the square root of t minus 1. Okay, so it seems kind of weird to do. It's like, well, why do we have to do that? But then it's really easy to graph an inverse on the same screen, because you just switch the x and y variables. So if we have y equals the square root of x minus 1, let's think about its domain. Its domain is going to be all values that are greater than or equal to 1. So 1 to infinity. And its range is going to be everything bigger than 0. Okay, the reason is because if you have a square root, the smallest that you can have under a square root is 0, right? You're not going to get negative numbers out. Okay. You could also think about what the graph looks like, and it looks like the square root function just shifted over 1. So if I find the inverse, then I switch my x and my y, and I solve for my new y. So I have x squared equals y minus 1. I add the 1 over, so I get y equals x squared plus 1. Okay, the problem is that's a parabola, right? And it's not 1-to-1. So what we're going to do on our calculators, we're going to graph the first one, x equals t and y equals the square root of t minus 1, and then we're going to graph the other one. So I'm going to go to y equals, I'm going to have x equals t, and then I'm going to do the square root of t minus 1. Oops, wrong thing. You might need parentheses for yours as well to make sure the square root goes over all of it, or you have parentheses t minus 1. All right, and then for the other one, we're going to find the inverse. So we're going to graph a second curve on here as well, and we're going to do the opposite. So we're going to do the square root of t minus 1. And t. Then we're going to hit graph. So when we hit graph, it's going to graph the first curve, so the first x1, y1 pair, and then it's going to graph that second curve after. So here's what we get. So here comes the first curve. So it looks like that, like we expected. But now when it's drawing the second curve, it's already taking care of the domain issue that we had. Right? It already we only have part of that parabola. We only have the part that we want. Okay, because we weren't graphing the entire parabola, we were graphing just the square root of t minus 1, which is always positive, right? So it's giving the x values are always positive, which is what we wanted. So we don't have to worry about the domain when we have parametric equations. So it's kind of nice if you don't have to do it. So our domain was really, so if we graph it here, the first one looks like this. And the second one ends up being, is that what it looks like? Oh, I did it wrong. It's plus 1, isn't it? Oops. I think I caught that on my own, guys. You should have told me a long time ago. All right, so we end up getting this. And then the second one, we get x squared plus 1, which is up here. All right, and it ends up being a reflection over the line y equals x.
Do you type x squared plus 1 into the x cubed, right?
Yeah, but you're hitting the x button, but when you hit it, it becomes t.
Right.
So it's the square root of t minus 1.
X2.
Yeah, so I had x1, y1, and I had x2, y2. So the first one I did t, and then I did the square root of t minus 1. And I said you might need parentheses there, depending on how old your calculator is. And then this one's going to be t minus 1 and t. So you just switch them. So it took care of the domain issue. Like when we found the inverse, we should really say its restricted domain is 0 to infinity, because it was the original range. Do you remember? So they're the same. All right. So your homework's pretty easy. All you're really doing is you're listing out a point. Like I say, what happens if t is equal to 5? Find the x value, find the y value. And then you're doing the thing where you remove the parameter. It's not bad. So you just have questions 1 through 8 on whatever page your last homework was.